Let's remind ourselves about the recommended ways that we can securely connect into our device, like our Cisco router. If we're wanting to get command line interface or CLI access, maybe we're using PuTTY or Terraterm or some sort of other terminal application, one option we might have is Telnet, but recall that Telnet is not secure. Data is sent in clear text. Somebody could sniff packets from the wire and see what password you're typing in, as an example. So let's not use Telnet when we want to get to the command line. A better approach, a more secure approach, is Secure Shell, or SSH. That's going to encrypt our traffic, so if somebody does capture the packets, they won't be able to read those packets. We might also access our router via a web interface, a GUI interface, and you can do that via HTTP, but again, HTTP is not secure. There is a secure variant of HTTP though, and that is HTTPS. And that's what we should use if we're trying to access our router interface via a browser. In addition to securely connecting to our device, once someone connects, we should probably challenge them, maybe with a password requirement or a username password requirement. And we've talked previously about how to set up a password for the console, for the line, and how to encrypt those passwords. Let's just review that real quick. Let's go over to one of our routers, and if we go into line configuration mode for VTY lines 0 through 4, I can say password is Cisco, and I'll say that a login is going to be required. We could do the same thing for the console line by going into line console 0 and doing the same thing, and once again we'll say password Cisco, and we do want to require a login. To make sure that that password is not in clear text though, we can say service password hyphen encryption. Now if I do a show run pipe to section line, we can see that these passwords are scrambled up. And we also demonstrated previously that the level 7 password is not all that secure. We can find multiple resources on the internet that will easily decipher a level 7 password. But we said if we're setting up an enable secret password for our router, that's a lot tougher to crack. Actually, it got even tougher with recent Cisco iOS. Let's go back to an older Cisco iOS version. This isn't too old. Let's do a show ver. And it looks like I'm running some version of 15.11T1, and I'm going to do an enable secret, and I'm going to use a really weak password. It's all going to be lowercase. It's going to be just 3 letters, and there are going to be no special characters. I'm going to use an enable secret password of cat. If I take a look at the running configuration, we can see that this appears to be scrambled up. This actually is not an encryption. This is a hash. It's using an MD5 hash. That's a level 5 hash in Cisco, and this is actually not as secure as what some other versions of Cisco iOS offer us. We could take an MD5 hash like this, and we could do a brute force attack. If it's a weak password like the one I used, just a 3-letter password, we could use a utility to try various combinations of letters until it stumbled upon CAT. It would run the MD5 hashing algorithm on CAT, and it would say, does this hash result equal this that I input into that utility? And if it's a match, it's going to say, oh, the password is cat. Let me show you how easy it is to do a brute force attack on a weak password like this. Let's highlight this hash digest. This is a 128-bit hash digest. I'm going to copy it, and I'm going to use a utility called Cain and Abel. And I am not recommending that you go download this utility. The security software on my computer complained quite a bit when I installed this software, but I want to show you what's possible, what some people might do. Under the Cracker tab, we have Cisco iOS MD5 hashes, and I can add one. Let's paste in the hash that I just copied from the router, and we'll say OK, and I'm going to do a brute force attack. Let's right click, say we want to do a brute force attack, and let's see how long it takes to crack the password of cat. I'm looking at my second hand on my watch right now, and let's start. And it took about 7 seconds, it looks like, and it told us that the password was cat. This would get much more challenging to attack via a brute force attack if it were longer, if I had 8 characters, if I had a mixture of upper and lower case, if I had special characters. But here, about 7 seconds or so, we were able to crack this password. And recently, Cisco has made this even tougher to crack. If we take a look over at R1, let's see if we do a show ver. I'm running 15.24 on this router. And if I do an enable secret here, let's do enable secret cat. Let's take a look at the running config this time. And you see this enable secret 4. It said 5 on the other router. Notice this is a longer hash. Let me show you what's going on here. If I say enable secret, a level 4 password is a SHA-256 hash, secure hash algorithm. And this is what a lot of the newer Cisco IOS is running. It's going to be even more secure than using MD5 as our hash, but always, as a best practice, let's make sure we have strong passwords. Yet another way of securing connectivity to our devices is to limit access to specific IP addresses or to specific networks. When I used to be a network manager at a local university, I remember doing this on our internet router, the router that connected out to the internet. I didn't want anybody on the internet telnetting into that router and getting to a prompt. So what I did, I set up an access class command on the VTY lines. This allowed me to say that in order to connect to the router, not through the router, but to connect to the router, the source IP address had to be within the university's network. And in the example on screen, we see a topology we used when we were working with access control lists, but let's use this to pretend that the network of 10.1.1.0/24 is the inside network, the trusted network, and let's imagine that 192.168.1.0/24, that's the outside network. That's somewhere on the big scary internet. And I only want to allow Telnet or SSH sessions to originate from the 10.1.1.0/24 network. Before we secure things, let's just make sure that the 10.1.1.0/24 network can telnet into router R1. Let's do a telnet to 10.1.1.1, and I can. Let's go to server 1, that's on the outside network. Can it telnet into, we'll say 192.168.1.1. That's the interface we're imagining is pointing out to the internet. And yes, it can. The outside and the inside networks can telnet into router R1. Let's fix that. On router R1, let's create just a standard access list. That's really all we need because a standard access list pays attention to source IP address information. I'll say access-list1 permit, and I want to permit the inside network of 10.1.1.0. We've got a 24-bit subnet mask, so that means our wildcard mask will look like 0.0.0.255. And this next command is optional, but I think it's a best practice. We could say access-list1 deny any source, and let's log it. Yes, there is a deny any implicit at the bottom of the access list anyway, but by giving the log keyword, that's going to allow us to have a record of unauthorized access attempts. Let's now take this access list and let's apply it to our VTY lines. Remember when we applied an access list to an interface? We didn't say access-list, we said access-group. Well, here in line configuration mode for VTY 0 through 4, we're not going to say access list or access group, we're going to say access class. And we will reference the access list of 1, and this is going to be in the inbound direction. Someone is trying to connect into the router. Now that we've created this access class, let's go back to PCA and once again try to telnet into router R1, and it is successful. Great news. We wanted to be allowed to come in from this subnet, but we did not want to be able to come back in from the outside. Server 1 should now fail in its telnet attempt. Let's try it. And there we see it on screen. The connection was refused by the remote host. This is a simple yet powerful way to further secure access to our devices by saying that attempts to connect into the VTY lines have to come from a certain IP address space. Oh, and one other thing we want to check. Since we did logging on router R1, we should be able to go back to R1 and see an entry. And here it is. We've got an entry that said 192.168.1.2, which is server 1. That IP address was denied when it tried to come into the router. And to sum up what we've talked about in this video, we began by talking about using secure protocols like HTTPS and Secure Shell as opposed to non-secure protocols like HTTP and Telnet. We reminded you of the process of how we encrypt passwords for our VTY and console lines. And we talked about a couple of ways that different Cisco iOS versions might create a hash value for our enable secret password. Some of the older Cisco iOS versions might use MD5, while some of the newer versions might use SHA-256. And then we wrap things up by showing you how we could limit access coming into the router via Telnet or via Secure Shell by creating an access list and applying that to our VTY lines as an access class. If we want to have users for our Cisco routers and switches, what we could do is have local users. To create local users, we can simply go into the command line interface and using the username command, set up users along with passwords, and we can even give different privilege levels, and that might be a good approach if we just have a few devices to manage. But for larger enterprise networks, that really doesn't scale very well. True story, when I went to work down at Walt Disney World in Florida, my first week on the job, they gave me a username and a password that allowed me to access hundreds of Cisco network devices. And obviously somebody didn't go to each device and add an account for me, or they didn't just want to give me the enable secret password to get to everything. Because when you've got a large enterprise like that and you have employee turnover, you don't want to give out the enable secret password. You want everybody to have their own account, and you want to be able to create it just one time. So what they did at Walt Disney World was, for their big network, they added an account for me on their Aaa server. Aaa, that stands for Authentication, Authorization, and Accounting. Let's talk about the 3 A's of AAA. First of all, authentication is all about proving we are who we claim to be, giving our credentials, like a username and a password combination. And this AAA server, in addition to having user accounts where we can authenticate ourselves, it can have authorization levels set. It can dictate what we have permission to do. That's the authorization component of AAA. And finally, accounting. That keeps an audit log of what we did do. Again, authentication is about proving you are who you claim to be. Authorization is saying what you can do, and accounting is saying what did you do. And there are different types of AAA servers. The two main types we have are Radius servers and TACACS Plus servers. Let's do sort of a side-by-side comparison of those. Radius uses UDP at layer 4, while TACACS Plus uses TCP at layer 4. Another distinction is that Radius is only going to encrypt the password as we're doing our authentication. However, TACACS Plus is going to be able to encrypt the entire packet. Another difference is Radius actually has a little better accounting than TACACS Plus, and if accounting is your main reason for having a AAA server, you might want to consider Radius. Another consideration is that Radius is standards-based, while TACACS Plus, that's a Cisco proprietary version of TACACS, so TACACS Plus is Cisco proprietary. But whichever AAA solution you might decide to go with, the big benefit is we get to create user accounts one time, and then the routers and the switches, instead of going into those devices and individually creating lots of user accounts, we can just tell them to point to this external AAA server. That's going to enhance the security of our network by not giving out an enable secret to everybody, and it's going to make it more manageable because we don't have to go to every device and create a user account on every device.